Before we get started, I'm currently creating a 12 to 24 weeks training course on smart contract development, auditing, and blockchain decentralized application automation. It's going to be a comprehensive training course, and mainly it will be a one-on-one section. I'm not taking more than 10 students at a time, and so that I can take you from any level you are in, whether you have written code before or you've never written any code before, and make you into an expert. If you are interested in this training course, please leave your comments below, and once my waiting list page is ready, of course I'll let you guys know. By the way, if you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. For the price feed, I'm just going to come down here. I'm going to define a struct that will always return, that will be holding the address of our ETH USDC, depending on the blockchain we are on. I'm going to create an instance of the struct just up here. Now I'm going to come down here and define three functions that will return price feed address, ETH USDC price feed address, depending on the chain we are on. If we are on Arbitrum Sepolia, this is what we are going to get. If we are on base Sepolia, we are going to get this. And if we are on mainnet, Ethereum mainnet, we are going to get this. So if you notice, I told you that you can have view here if you are not making state changes to these functions. Well, another keyword is pure. You use pure when you are not making state changes and you are not reading from the storage of the contract. You are just returning a constant. So maybe you do a basic calculation and you return it. So you can restrict the function to pure. All right. So let's move on. So I'm going to come into the constructor here, and I'm going to write this if statement. Depending on the chain we are on, it's going to call the right function. All right. This is not perfect because we need a mock here, but I think this will do. Right. We can now come back to our interaction script. Here, and everything should be okay now. Let me try and compile again and see. Command J. Let me clear my terminal. So I'm going to run forge build. Everything seems to be okay. Yeah, everything seems to be okay. Since everything is okay, then let's stop this and restart our blockchain. And let's see if we can deploy again now that we have our message. Before we didn't have message. All right, so hopefully everything goes well. The blockchain is up and running, so I'm going to run mock deploy. Make it deploy rather. So it's deployed. The next thing is to fund the contracts. Make get worth and fund. That is also successful. Then the last thing is to now bridge. And what do you know? Everything is working well. Yeah, everything is fine. Yeah, I can now delete the excesses. So yeah, I can come here now. And one more thing I want to do before we proceed. Let me bring up this cursor because I need to put comments. So I can come here now. So in order to document what we have done so far, what each function does, this is where this will be quite important. All right. So this is how we do it in Solidity. This helps us to define what each parameter does. So I'm just going to come here to this external function. Come down here. It has given me the option. All right. That's the power of AI. Okay. So much all right going on here. Then what else? I think yeah, that's all. Yeah, for the aerodrome. Yeah, everything is okay now. That's good. For this, okay, same thing. Yeah, put the parameters, and for aerodrome, that's okay. Yeah, yeah, that's all. Oh, now to be sure of what we are passing in, I'm just going to copy this just for now. I'm going to paste it here. Okay, we don't need this anymore. And I can just this empty down here. I'm just going to paste what I've just copied so we can follow. Now, so let's come down here and define our message. The empty one, we can just comment it out. So all we are doing is this is the name of the library, and I'm calling this function on it. Now it takes this parameter. The first thing is the address of our cross-chain caller on Arbitrum on the destination chain. We've not defined that, so that's one thing. Token in the token we want to put inside Uniswap V3, which will be wrapped Ethereum in Arbitrum, and USDC, that would be USDC address on Arbitrum. That's what the token we want to get out. So Uniswap will take this and swap it to this for us. This is the Uniswap V3 pool fee, the particular pool we want to swap on in that Uniswap V3 pool fee. All right, we've defined that earlier. Now we've not defined this. This will be the price feed for Chainlink on Arbitrum, the price we are interested in. So we need to supply this. We need to work on that. The output amounts when we bridge. Yeah, we did this. And user address, we also have not defined that. So let's go to our helper config and define the missing values. I'm coming here now. Copy this. And I'm going to come down here. Okay. This will be address to be public. Okay. So let me get this address now. Now these are all the values we need. Let me just define them here. So I'm using user address. This is my development wallet address. There's no token on it, so that's the address. This is wrapped Ethereum. Okay, we've defined it up here. Okay, sorry. Let me just remove this too. Now we need USDC on base address. We need USDC on Arbitrum address. We need cross-chain caller on Arbitrum. So this is the cross-chain caller address on Arbitrum. We don't know it yet, so I'm using a random address. The same thing for on base, the cross-chain caller on base. Again, I'm using a random address because we've not deployed on live testnet yet. So yeah, what else do we need? Okay, I'm going to come down here and define the pool fee and relayer. Relayer is zero address because we are not using relayer. So this is zero address. Before we continue the coding, let's quickly see where we are. So far we've completed and tested our cross-chain color contracts on the base blockchain. And so we've been able to interact with it. So on this side of things, we are okay. We've completed this side of things. So what we have to do is to move to this side of things, Arbitrum. And I promise you, it's not going to be as long as what we've done here. It's just to remove this aerodrome function for swapping on aerodrome, because aerodrome is not available on Arbitrum. So every other thing will be as usual. All right. So we can go back and continue our code. So we need to create exactly this contract for Arbitrum side of things. So the first thing is to just come here. Now I'm going to create a file. I'm going to name it crosschain color dot so. All right. So it's going to have everything, all the functions here. I'm going to copy everything and paste it here. All right. I'm going to copy the name of the file and change the name of the contract over here, up here. All right. Then the things we don't need, aerodrome, we are going to delete those things, because as I said, aerodrome is not available on other chains. We will be able to deploy these contracts on any other blockchain except Base blockchain, because we have a special contract for Base. So I'm just going to come down here, swap on aerodrome, everything. I'm going to delete this, goes with it. This amount on aerodrome goes with it. I think, is there anything else? Yes, here. And everything seems to be okay now. I'm going to come over here and do something similar. So the next thing is to go and deploy. Now we can move a bit faster, since this is exactly what we've done before. So I'm going to come to this script folder, and I'm going to create a deploy script here. So the file is named deploy crosschain color, and as before, we import the things we'll need. Right, I've not defined this, because when we are deploying the crosschain color contract over here in the constructor, it takes across spoke for Sepolia. So I'm going to come here and define it. So as before, I'll just come here, and this is the across spoke for Arbitrum. I got it from the documentation of across protocol, multi-core handler here too. And this, okay, I've repeated this. So let me just comment out this one. I'll just remove it totally. So this should be okay now, because we've defined all of them. The next thing is to come here to the make file and state define the command to deploy. So just as before, we are calling the deploy contract, deploy cross-chain contracts script from this file, from this, yes, over here. That's what we are calling. So let's now test. Going to hide this. Command J brings up our terminal. Let me clear the terminal. I'm moving a bit faster because everything we are doing now, we've done it before. So the first thing is to start up our terminal, our blockchain. So over here, here's the make file. All right. So I'm going to be forking Arbitrum now. Before we were forking Base. So now we are testing on Arbitrum. Make. So it's still going. Once it's okay, so it's up and running now. I'm jumping to the next terminal and I'm deploying, and let's see if everything works well. And so far everything seems to be working well. Okay, we have an error. The error has to do with the this thing we are using, the JSON RPC we are using to connect with Arbitrum Sepolia, because it's publicly available, so sometimes it behaves abnormally. So I'm just going to restart, and let's try it again now. I've restarted. Hopefully it goes well now. Let me be sure it's on now. Still going. It's because of this public RPC. The next thing is, let's try this now. I think it will work this time around. Okay, then it's been deployed. We have our contract address, so everything is okay. Let's now write interaction contracts similar to this, but in this case we'll be writing it for Arbitrum cross-chain contract. So as before, I'm going to create a file. I'm going to name it interaction with cross-chain contracts.s.so. I'm going to come here and copy everything we'll need as before, and come here, back here, paste it. I need to change this, so I'm going to come to my deploy script here, because this is the contract we'll be working with. So this is what we need now. That's good. I'm sure you remember that when we're interacting with the base contract, we needed to fund the contract first. So we need to do the same thing here too. We are going to fund the contract by writing get worth and fund contracts. This, so you can see the major difference here now. We are calling wet Arbitrum Sepolia, that's the address we are using here. And we are calling transfer on the Arbitrum side of things. All right. Now we can now transfer, since we've been able to fund the contract. This is it. Let me remove the unnecessary comment here. All right. So it's just like what we did before. I would even want, let me uncomment this so that we can see our encoded messages. So swap message, so it's in bytes. So that's why I'm using console log bytes to display the message we would have encoded here. So this one, we are doing the reverse of what we did in this contract. In this contract, we are transferring from base to Arbitrum, and we are calling Arbitrum. We are sending message to Arbitrum to swap on Uniswap v3. But in this case, we are calling base Sepolia and Uniswap v3 on base Sepolia. That's where we are swapping from. So you can see the message we have encoded, the pool fee. You can see the price feed address is in base here. When we did it here, the price feed address was in Arbitrum. So I just wanted you to pay attention to the difference. All right, this is just a way to keep track of the contracts we have deployed. So I'm putting the cross-chain caller address on base. We are saving it on this contract on Arbitrum. All right, so after this is done, this is where we call our bridge token to other chain with message function. We pass all the parameters, and we will also try and log the balance afterwards. So yeah, that's it. Please feel free to pause the video, copy the code, and let's write command for this as well. So over here, make file. This is the command to fund the contract on Arbitrum. For to bridge token over here from Arbitrum to base, this is the command. You can see we are calling transfer from Arbitrum to other chains using multi-core handler. Here, that's exactly this script over here. This script transfer from Arbitrum. All right, so that's it. Now to the moment of truth. I'm going to hide this. I'm going to Command J and bring up my terminal. I'm clearing up the terminal, stopping the running the blockchain running. So I'm restarting it now. It's up and running. And the first thing is, okay, let's just wait for it. It's slower because it's on. I seem to be having problem with the JSON RPC URL I was using earlier. So I've replaced it. Let me show you .env file. So you can see I just found this one on chainlist.org that I showed you earlier. I've removed the previous one. So hopefully this one works better now. So as before, I'm going to start up our network, and this is faster. So the next thing is to deploy on it, and it has deployed. This is a lot faster and better. All right. The second thing after that, then we need to fund. So I'm going to run get worth, run this command now. Where I'm going to write make get weight and fund contract on Arbitrum. Hopefully everything goes well. Yes, we've been able to fund our contract on Arbitrum just as before. Got weights in my wallet and transferred. All right, the next thing now is to try and attempt to bridge. So let's be hopeful. I'm going to run make, then bridge. Now we want to bridge from Arbitrum to base. And what do you know? Everything works well. This was the message we encoded here. So everything. Quickly, let me show you the interaction script. So we check the balance after. That's the worth balance, and it's 0. You remember we funded it with 100. So yeah, this were the parameters we sent along in our. Let me show you the library. This was the library. Yeah, yes, yeah. All this that I comment. Yeah, I was exposing, so I can just uncomment them. That's why they appeared here. All right. So that's good. Now I need us to test. Now we can deploy our contracts on live testnet. Let me just hide this. So I'll come here now. Yes, we've done everything. We can deploy on testnet, but I need to be sure that swapping Uniswap V3 swap. I need to be sure that swap on Uniswap V3, this function is working. So I'm going to come here and I'm going to write a script to test swapping on Uniswap V3. Once we are able to do that, then the next thing is to deploy on testnet and actually perform the transfer on the testnet from base Sepolia to Arbitrum Sepolia and see if we're going to receive our token. So let's get started. I'm going to come just over here and we're going to write our script here, which will be for us. Okay, let me just hide this and disable these autocomplete. All right. So the name of our script is perform swap on Uniswap v3. Then okay, so as before, we write there is run function that will call this contract for us. That will call this function for us. So over here, so I'm going to just come down here and write the function itself, function swap on this. Just going to make it public, just as we've been doing it. All right. So here, let's quickly look at what we are going to write, the function we are going to call. This is its cross-chain caller. We are calling swap on Uniswap v3. So I'm going to call this, close. I'm coming back here now. So it makes it easier for us to know the parameters we are passing in. I'm just going to come in. And out of curiosity, I would want us to see the Chainlink price. The price Chainlink is going to give us. I'm going to copy these two. We are going to go back, and that will be up here. So these are the things we need. I need you to pay attention to something over here. Whoever calls this function, he has to approve our contract to take this amount in from that person before the swap can be performed. All right. So it's not like we are funding the contract now, but we don't need to fund the contract. The amounts will be taken from our wallet directly. So we need to put that in mind when we are doing our implementation. So over here, to get the price first, let's import the things we're going to need. Again, we're going to need our epoch config, the price feed address of ETH USDC. We are calling it on Arbitrum. All right. So we just want to know 1 unit of worth, how much it will cost in USDC. So this we are calling get amounts out on Chainlink, this function, which takes the price feed, which we already have. It takes the amount in, it's going to be 1 unit, and it takes the worth decimals, which we already have. Worth decimals, we don't have that. So you need to come here and define it. So we're going to come here now to our helper config, just anywhere down here. So worth decimals for wrap Ethereum, it has 18 decimals. USDC has 6 decimals. All right. So let's go back to where we came from. Now we can do our swap. So we'll be having VM start broadcast, VM dot stop broadcast. Okay. So we'll be approving and calling the function inside here.